Today, I'm going to talk to you about symmetry and why throughout your life you have seen complex mathematical equations which you don't understand, and its derivations which you don't understand, and still whenever you talk to a physicist they show you the equations. So you have to understand equations, you have to understand the expression, left hand side there should be something, right hand side there should be something, and you have to do that. But I'm telling you that you don't have to do anything. You just look at the data and you can determine what is the physics going on inside, what is happening in nature, and what is happening in the universes. Suppose somebody has measured some data. Normally they represent with a grid like box, okay, and there is a horizontal axis, there is a vertical axis, and say horizontal axis there are 16 boxes, and vertical axis there are 16 boxes. So 16 square, 17 square, 19 square. It could be 1000 square, or 50,000 squares, and then all this kind of squares they change. So how do you do that? We have identified 15 different kind of symmetries by which you can look into it. For an example, centrosymmetric, part-symmetric, it could be Kronecker fractal symmetry, it could be circulant symmetry, and just by looking at the symmetry you can tell there is a quantum phenomenon going on or classical phenomenon is going on. For an example, if you see Kronecker delta or matrix product symmetry, you can say that it is fairly quantum. And if you see just symmetry, vertical reflection symmetry, upper part of the grid has similar values at the lower grid, and or could be vertical symmetry, left side has the similar as the right side. So similar type of values, you can understand those symmetries. But the question is that if I understand that, okay, there is a possibility that this kind of data is representing a classical or quantum phenomenon, but how do I understand what is happening in the system? You have to look at this grid and the values, how they are changing with as a function of time. If you do that, then you will be able to understand that some of the symmetries are coming back after some time. So there is a loop of symmetries or set of symmetries, reflection symmetry, rotational symmetry, translational symmetry, or product tensor symmetry are in a loop. So you understand, sometimes classical features are dominating, sometimes quantum features are dominating, but you have a loop. So the periodicity of symmetry appearance, and there should be some tolerance of this kind of symmetries when we can detect. You can find out a governing rule in the universe, so you can discover a rule. So without knowing anything, you can predict what is going to happen in the future. So this is how we build up the self-operating mathematical universe, where we do not suggest to have any mathematical equations or anything. We build on the whole thing based on just looking into the data. Then there could be interleaved or alternating symmetry classes. So that is symmetry, say 1 and 4, alternately in a regular rhythm. Like symmetry 1 or say rotational symmetry goes to vertical reflection symmetry. Okay. And again rotational symmetry, again vertical reflection, again this kind. So symmetries are interleaving. So you can have one loop of symmetry, another loop of symmetry. If particular this condition is attained, then another loop runs. So you can find interlacing or interleaving of symmetry. Then there is 4 fundamentals of quantum behaviors. That is superposition, that is entanglement, that is to quantum tunneling, where one entity, one symmetry appears, another symmetry disappears. Some symmetry is localized, and in this particular box symmetry means different boxes have different similarity. Box in the northeast corner at a particular discoordinate in the grid are similar to another tensor in a different grid. So when you have this kind of quantized burst behavior, that is quantum symmetry. Quantum symmetry means, say I said we can classify, say 15 different kind of symmetry. So if we can identify all of them, and we can see that quantum is one quantum symmetry is going to another quantum symmetry, and they are in a cluster, and one symmetry disappears, all others are changed into different symmetry, superposition. One symmetry disappears and all others they disappear simultaneously or fixed. They do not change at all. Entanglement. One symmetry was block symmetry here. It disappears from here and appears here somewhere around in the grid. We are talking about this whole screen is a grid and boxes are everywhere. So now you have these kind of situations, and you see that some tensor, some boxes of symmetric values which were there, and it goes somewhere else, and you find that in a pi frame before, in a past time, the way it was changing, and now it is showing a different kind of contextuality. And when you go back and you check, you find that okay, the whole perspective of the present and the future has changed. Then you say quantum retroactiveness. So these four fundamentals of quantum you can detect. And phase shifted cycles, when three or more symmetries, for an example, say symmetry number 2, symmetry number 6, and symmetry number 9 appear in a fixed offset, say 2, 6, and 9. So you find that sometimes 2 after a periodic time interval, 3 and periodic time interval, symmetry number 6. So when you have these kind of situations, then you can understand that you are having a phase shifted cycle. If you are seeing there, that means the system, whether you know anything about this system or not, doesn't matter. That system has generated a condition where you can do entanglement Fourier transform, fast Fourier to Fourier, quantum Fourier transform measurement, and you can detect what are the symmetries that is governing the particular phenomenon. So you can complete your understanding. So this is how you can get a perspective. This is very very short description, but I wanted to just give you a hint that if you simply look at the symmetries, combinations, and you try to understand what is going on, you can tell a lot about what is happening around you without knowing anything. So that's why a futuristic intelligence, correlation-based intelligence, and interpretation of raw data based on symmetry could be established. And we can create a new kind of computer out of it. And even our computer, our quantum computer, our brain jelly, and then where we want to realize the brain functions, all are based on this particular concept. Now I would like to show you different examples of different tensors, how it is, and you can see by yourself how different ways we can understand this tensors. So this is screen that you are looking at, and you can see that there are four. The top left is symmetric tensor, then parsymmetric tensors, then you have centrosymmetric tensors with respect to center. The bottom left and bottom right is the supersymmetric tensor. So I just wanted you to have a look and how does it look like. So just to get an idea that what the data would be, raw data, and from which you can get a beautiful understanding of what is happening in nature.